My name is Jonathan Hicks. We're doing coordinates. Now, coordinates are very important in maths. We use them a lot in geometry. So if you're doing transformations, for example, like rotations or reflections, you need coordinates for those. But also if you're doing algebra, surprisingly enough, often in algebra, if you have an equation, you then plot it on a graph. And in order to plot equations on graphs, you need to understand coordinates. So it's important for a variety of different topics within maths. What is a coordinate? Let me draw a number line first of all on here, and then I'll explain. Okay, here's a number line. Now, I want you to imagine that you are a dot and you live on this line. So you can travel upwards and downwards along the line, but you can never get off the line. You spend your entire life living on this line. So maybe you are here, for example, at one particular point. And in order to make sure that you don't get lost as you travel up and down the number line, we have all these numbers that identify where you are. So at the moment you're at 2. Maybe you later on travel in this direction and you end up at -1. Or you could be at 3.5. But you can only travel upwards and downwards along the line. We say that you can only travel in one dimension. There's only one direction, as it were, that you can move, and it's got to be along that line. But life is not very interesting for you because you can only move along this one line. Life would be much more exciting if you could move out here. So wouldn't it be great if you could go to that point there? From over here you look at this point and think, wow, that looks very exciting. I'd love to move over there. If only I had some way of measuring the up and down movement as well. And if you imagine a giant piece of paper here, coordinates are a way of expressing positions on a two-dimensional space. So you don't have just one dimension which you can move, but you also want to move up and down as well. Let me draw another number line on here to help us work out positions in the up-down direction, and then I'll explain. Alright, so now I've got two number lines. I've got one number line that goes left and right, so we've got negatives over here through to positives here. And then I've got another number line that goes up and down. So the negatives go down in that direction, it gets more and more negative. And going up, we get to the positive numbers and they get bigger and bigger going up. So now my dot is very excited because you can move around anywhere in this plane, as we say, anywhere in this flat space. So the dot might end up being here, for example, and we could say that this was 3 on this number line and it's at 1 on that number line. So I can work out where the dot is, and the dot's not going to get lost wherever it is on the whole piece of paper. So if he was down here, for example, I could say he was at -3 on this number line and then at -2 on the up-down number line. But it's a bit confusing when you've got two different number lines, which number line is which. We need some way of labeling them, of identifying the horizontal number line from the vertical number line. Now you can give them any label you like, really, but in maths we always like to be consistent, and so we always label the horizontal number line X, and the vertical number line, you probably know by now, is going to be Y. So if I want to plot a point on this graph, on these coordinates, coordinate axes as we call them, then, oops, let's put that in as well. Then I can express it using the X coordinate, the X number line, and the Y coordinate, or the Y number line. So if we go back to this point where we had 3 and let's say 2 up here, incidentally, when you plot points in maths, you shouldn't do it using dots like that. You should do it using crosses. So that would be the point, 3 for the X and 2 for the Y. So the X coordinate at this point we'd say is 3 and the Y coordinate for this point is 2. But as I say, you should plot using crosses rather than dots because they're more accurate. Now, there's a way of representing that coordinate separately. So apart from seeing where it is on the axis here, if you want to just write down where it is when you're describing something, then we have this notation involving brackets. So coordinates then, let me just put a little title here, coordinates. So typically a coordinate always consists of two parts in brackets. It's two numbers. The first number is always the x coordinate and the second number is always the y coordinate. So this point here would have the coordinate 3, you put a comma in between and then 2. So that means the x coordinate is 3, the y coordinate, which is always the second one, is 2. So in general here, this first one is always the x coordinate. Usually you abbreviate coordinate to just coord. And for the x coordinate, if the number here is positive, I'm going to write plus VE, that's a common abbreviation for positive, then that means you're going to the right. But if the x coordinate here is negative, so minus VE for negative, then that means you have to go to the left. So, I mean, that makes sense if you look at the number line here. The positive numbers always go to the right, the negative numbers always go to the left. And incidentally, you should put an arrowhead on the direction in which the numbers are increasing. So because the numbers are getting bigger in this direction, you put your arrowhead here. On the y-axis, the numbers are getting bigger as you go up, so the arrowhead points up. That's why we put the arrows on there, so you remember which way they go. Oh, and one other important thing that I've forgotten. You may have noticed there's no 0 here. Now the two axes cross at 0, and rather than trying to squeeze one 0 in here and another 0 here for the both axes, you just put a sort of ring around the crossing point, and that is known as the origin. It's 0 on both axes. But coming back to my coordinates now, so the first one is the x coordinate, the second one here is the y coordinate. And again, if the y coordinate is positive, so like 2 here for example, that means you're going up. But if it's negative, that means down. Which again just matches the axis. Positive numbers go up, the negative numbers go down. So this thing in brackets with a comma in middle is called a coordinate. It tells you where a point is. And that's the pointer coordinates, is to identify where points are on this sort of giant piece of paper. So if you ever get lost and, oh, I'm not sure where we are, look at the two numbers. So I'm at 3 on the x, okay. I'm at 2 on the y, oh, okay. Now I know where I am. I'm at 3, 2. So let me just give you an example of a couple more coordinates and then you should get the hang of it. So if we had minus 3, 1, that means minus 3 for the x coordinate and 1 for the y coordinate. Now with coordinates, you always imagine starting from the origin. So you can go minus 3 in the x direction, because the first number, remember, is always the x coordinate. The first number always tells you how far left or right you are. And because it's negative, that means it's going to be left where the negative numbers are. So minus 3 for the x coordinate means you're going to be somewhere on this point here. We don't know how far up or down we are yet, but we know we're going to be somewhere above or below minus 3. The second number then, the y coordinate, is 1. So y coordinate, remember, is always the second number, and it's positive. 1 is positive, so that means you go 1 up. So minus 3 and 1, so minus 3 for the x, then up to 1 for the y, so I put a cross there. Like so. And sometimes you label the points on the graph, so I could write next to that, in brackets, minus 3, 1, and that means that this point here is at minus 3, 1. I mean, you can see that looking at the graph anyway, the axes, so you don't necessarily have to write it, but sometimes you'll be asked to put the coordinates on the graph. Okay, let's try another one. Let's have 0, 4. Now then, if the x coordinate, the first one, remember, is always the x coordinate. If the x coordinate is 0, that means you don't go left or right. You're at 0. So you're actually on that point there for the x. But the y coordinate, the second coordinate, is 4. It's positive, so we're going up. So you go 0 left or right from the origin, and then you go up by 4. So from here, go up to 4. You're actually going to be on the axis there. because you're at 0 as far as the x is concerned, but you're at 4 as far as the y is concerned. So that's what that one would look like. Let's do a couple more. So if we have, go over here now, let's have -3, -2. So for this one, the x coordinate is -3. So from the origin, go 3 to the left until you're at -3. The y coordinate is -2. So y, remember, if it's negative, it means you're going down. So having gone to -3 on the x, you go down to -2. There it is on the y. So it's where the -3 and the -2 meet. -3 and -2, they're going to meet here. So you put a cross there. So that would be the point -3, -2. Alright, I'll do one more. Let's imagine we've got 2, 0. So this time the x coordinate is 2. So from the origin, you go until you find 2 on the x, so you're going to go to here. So the left-right movement was 2. It's positive, so we went 2 to the right, where the positive numbers are. The y coordinate now, though, is 0. That means you don't go up or down. If you look at the y number line, -3, -2, -1, 0, 1, 2, 3, the 0 is there. So in terms of your up-down movement, how far you've gone, you actually haven't gone anywhere. You're at 0, you're at this point here in the up-down direction. So 2, 0 would be on that point there. So the 0 ones often cuts people out, so just be aware of that. If it's 0 for the x or the y, it just means you don't move anything in that direction. So always work out the x coordinate first, then the y coordinate. Remember, in the coordinates, the x one always comes first before the y one, and you always start from the origin. But the point of coordinates is just to tell you where something is in this giant piece of paper, this giant flat plane or two-dimensional space.